Imagine standing on a beach, looking out at the endless ocean. You see water stretching as far as your eyes can see, but you know there's more beyond the horizon. Now, replace the ocean with the universe. For centuries, humans have asked, does the universe have an edge? Is there a point where space just ends? If so, what's beyond it? For that matter, is it even possible for something to have no edge at all? These are the kinds of questions that keep scientists, and most of us, up at night. Here's the thing. The more we learn about the universe, the stranger it gets. What we call the edge isn't a physical wall, like the edge of a room. It's something far more complex, tied to the very nature of space, time, and light itself. By the end of this video, you might not only rethink what the edge means, but also how much of the universe we can never see, and why that might be one of its most profound mysteries. Let's start by clearing up a common misconception. When people hear edge of the universe, they imagine hitting a wall at the end of space, like reaching the end of a road. But that's not what scientists mean at all. Instead, when we talk about the edge, we're really talking about the observable universe, the part of the universe we can see. It's limited by two things: the speed of light and the age of the universe. And here's why that matters. Light takes time to travel. If you look at the moon, you're actually seeing it as it was about 1.3 seconds ago. If you look at the sun, that's what it looked like 8 minutes ago. The farther you look into space, the older the light you're seeing. Now, imagine looking so far that you're seeing light from galaxies formed billions of years ago, not long after the Big Bang. That's the farthest we can see, the edge of the observable universe. And because the universe has been expanding all this time, that edge is now a whopping 93 billion light-years across. Here's where it gets even stranger. The observable universe is only a fraction of the whole universe. Beyond that, there could be anything. So how do scientists figure out where this edge is? It's not like we can take a tape measure into space. Instead, they rely on light, nature's ultimate time capsule. The most important clue comes from something called the cosmic microwave background, or CMB. This faint glow of radiation is the oldest light in the universe, dating back to just 380,000 years after the Big Bang. It's like a snapshot of the universe as a baby, and studying it has helped us map out the observable universe. But light isn't the only clue. Scientists also study the redshift of galaxies. When a galaxy moves away from us, its light gets stretched, making it appear redder. This redshift tells us how fast the galaxy is moving and how far away it is. Using this data, we've learned that the universe isn't just expanding, it's accelerating. However, no matter how powerful our telescopes get, they'll always be limited by the observable universe. That's because some regions are moving away from us faster than the speed of light, due to the expansion of space itself. Light from those regions will never reach us, no matter how long we wait. Imagine being on a boat in the middle of the ocean. You see the horizon all around you, but you know there's more ocean beyond it. The horizon is like our observable universe, a boundary set not by the actual size of the universe, but by the limits of what we can observe. This brings us to the ultimate question: what lies beyond the observable universe? One possibility is that the universe is infinite, continuing forever in all directions. If that's true, there's no edge, just an endless expanse of galaxies, stars, and planets. But this raises its own questions. How can something be infinite? And if it's infinite, does it mean there are infinite versions of you out there, living slightly different lives? Another theory is that the universe is finite but unbounded. Think of the surface of a sphere. It has no edges, but it's still finite. You could travel around it forever without ever hitting a boundary. If the universe works this way, space could curve back on itself. If you traveled far enough in one direction, you might eventually end up right back where you started. Then there's the idea of a multiverse. This suggests that our universe is just one bubble in a vast sea of universes. Each bubble could have different laws of physics, different types of matter, and even different dimensions. Beyond our observable universe, there could be countless other universes, each as unique and mysterious as our own. Of course, we have no way to test these theories, at least not yet, but they remind us of just how little we know about the cosmos. So, why should we care about what's beyond the observable universe? For one, it changes how we see ourselves. Are we part of something infinite, or just a tiny piece of a much larger puzzle? The answer could reshape everything from science to philosophy. It also pushes the boundaries of our technology. Every new telescope, every new discovery, brings us closer to answering these big questions. And along the way, we learn more about our own planet, our own galaxy, and our place in the universe. But perhaps the most profound reason is this. Exploring the universe reminds us of the sheer scale of existence. We're tiny, a single planet orbiting a single star in a single galaxy among billions. Yet, despite our smallness, we're capable of asking these big questions, and that's what makes humanity extraordinary. Now it's your turn to think about this. What do you believe lies beyond the observable universe? Is it infinite, finite, or something we can't even imagine yet? Drop your thoughts in the comments below. I'd love to hear what you think. And if you enjoyed pondering the mysteries of the universe, don't forget to like this video and share it with someone else who might enjoy the journey. The more we learn, the more we realize how much we still don't know.